Let's take on some example to solve implicit differentiation by using method number 1. We're going to find dy or dx of the equation using implicit differentiation in method number 1. The very first example is example number 1. If the given expression is in this form, 2x squared plus 1 over y equals to 2. If this is the given equation, what we're going to do here, we're going to find the implicit differentiation. To find the implicit differentiation, we're going to take the derivative of this term with respect to x, this one with respect to x, and constant with respect to x. But let me first pull up y to the numerator to become y to the negative 1. I have 1 over y, so just pull up this y to the numerator. Its power, which is positive 1 here, will become negative 1 in numerator. Now to take the derivative of 2x squared with respect to x, and derivative of y to the negative 1 with respect to x, and derivative of 2 with respect to x. So its derivative will be 4x plus negative 1 to the negative 2 times dy or dx equals to 0. We are taking everything with respect to x. We know that in method 1, to find the implicit differentiation, we need dy or dx. So to find the dy or dx, we're going to take derivative of everything with respect to x, not with respect to y, remember, because we need dy or dx. Sometimes your independent variable is y and your dependent variable will be x. So in such case, you may need dx or dy. In case of dx or dy, you have to take the derivative of everything with respect to y. But right now, I need dy or dx. So I need everything with respect to x. Therefore, derivative of 2x squared is 4x. I have no problem. Just apply the power rule here. Derivative of inner function, which is x. Derivative of x is 1, so I don't need 1 here. But the issue is here, when you take on derivative of y variable, it is y to the negative 1. So derivative of y to the negative 1 with respect to x will be the same as we did for 2x squared. Apply the power rule here. To apply the power rule here, I will have negative y to the negative 2. But remember, don't forget the derivative of the inner function. Apply the chain rule here. Derivative of y, this y, dy with respect to x. We know that this y has some hidden x property. Because of this hidden x property, we take derivative of y with respect to x. Derivative of constant, which is 2, equals to 0. Derivative of any constant is 0. Look, if we apply the chain rule here, we can apply the chain rule here as well. The inner function is x here. What is the inner function? The inner function is x here. When you apply the power rule, it becomes 4x. Derivative of 2x squared is 4x. Then we have to take on the inner function, which is x. So times derivative of x with respect to x will be 1. 1 times 4x will be the same 4x. Therefore, normally we don't write dx or dx. But since it is y variable, therefore my inner function is y. So you have to write dy or dx. You have to take on the inner function. This is what implicit differentiation means. Apply the chain rule here. In method 1, what we need? In method 1, we need dy or dx. So just take dy or dx out here. Open the parentheses, I will have 4x minus 1 over y squared times dy or dx equals to 0. Now to take out the dy or dx, I will have 1 over y squared times dy or dx equals to 4x. It is in negative. When it goes to the right side, it becomes positive. From negative sign, it will become positive. Positive 1 over y squared times dy or dx. Now, multiply both sides by the y squared, so we're left with the dy or dx equals to 4x times y squared. What I did when I multiplied y squared with 1 over y squared, this y squared will cancel with the y squared. I left only with the dy or dx on the left side and 4x times y squared on the right side. This is going to be the final answer. This is the implicit differentiation of the given expression by using method number 1. That's how implicit differentiation takes place. Example number 2. X times y plus y equals to 2. To find the implicit differentiation, I have to take the product rule here. I have the product of two functions, x and y. So I'm going to apply the product rule here. Let me do the implicit differentiation here. I just applied the product rule here, x times y. Derivative of x is 1 times y, put y as it is, and then plus, then put the first function which is x as it is and take the derivative of y which is 1, then the derivative of the inner function which is y, so times dy or dx. Look, we got 1 by applying the power rule on y. How to apply the power rule here? The power of y is 1, but normally we don't write, so 1. When you apply the power rule, 1 will be subtracted from 1 like 1 minus 1. So 1 minus 1 is 0. Whenever you have the power of 0 of anything, it will be 1. So y to the 0 will be 1. But we can't avoid the inner function. This y is inner function then. We applied the power rule in the first process. In the second process, we're going to take on the inner function, which is y. As I said, this y has some hidden x property. Therefore, I'm going to take the derivative of the inner function, which is y, with respect to x. Just apply the product rule here. Even you can apply the chain rule here for the x as well. But when you apply the chain rule for the x, which is the inner function, derivative of x is 1. So 1 times 1 will be the same 1. Therefore, we don't need the chain rule for the x. For the y, we do here. Similarly, derivative of 1 is 1 and then times dy or dx. It will be 1 minus 1. So 1 minus 1 will be 0, y to the 0 will be 1, and then apply the chain rule on the inner function, times the derivative of y with respect to x. Derivative of constant 2 is 0. Solve it further, you will get y plus x times dy or dx plus dy or dx equals to 0. I have two terms with the dy or dx, so I'm going to take dy or dx common from these two terms, and we'll bring this y to the right side to become negative y. It will be x times dy or dx plus dy or dx equals to negative y. Take dy or dx common from the left side to become dy or dx into x plus 1 equals to negative y. Since I need dy or dx here, when you divide both the sides by x plus y, this x plus y will cancel with x plus y. I will have x plus y in the denominator for the right side. So I can write that dy or dx equals to negative y or x plus 1. This is the final answer. This is the implicit differentiation of the given function by using method 1. This is going to be the final answer. Example number 3. If the given function is in this form, 1 over x cubed plus 2 over y squared minus y equals to y to the 4. Before to go for the implicit differentiation, I'm going to bring this x to the cube to the numerator to become x to the negative 3. Similarly, this y squared to the numerator to become y to the negative 2. To find dy or dx by method 1, do the implicit differentiation, therefore take derivative of everything with respect to x. dy or dx. I need dx in the denominator. My independent variable is x. Therefore, I'm taking everything with respect to x. They may ask that find dx or dy. If they need dx or dy, then you have to take everything with respect to y. It is just a matter of independent and dependent variables. After taking differentiation, I will have negative 1 over x to the 4. Remember, derivative of 1 over x cubed is negative 1 over x to the 4. Just apply the power rule here. Similarly, apply the power rule here for 2 over y squared. It will be negative 2 over y cubed times dy or dx. Don't forget dy or dx. Similarly, apply the power rule for the y here, which is 1, and then times the derivative of the inner function, which is dy or dx. Apply the power rule here as well. So derivative of y to the 4 is 4y cubed times the derivative of the inner function, which is y. It is dy or dx. Look, apply the same procedure for all the terms. But the difference is that whenever you have the y terms, you have to take the chain rule for the inner function. If you forgot, just go back and check the section of chain rule, how to find the chain rule. In implicit differentiation, there is a common understanding that this y has some hidden x property. Because of this hidden x property, we take derivative of y with respect to x. Simplify it further, I will have negative 2 over y cubed times dy over dx minus dy over dx minus 4y cubed times dy over dx equals to 1 over x to the 4. I just took negative 1 over x to the 4 and put it on the right side to become positive 1 over x to the 4. Similarly, I picked this term from the right side and brought it here to the left side to become negative 4y cubed times dy over dx. So whenever you bring any value from one side to the another side, its sign will be changed. It becomes positive 1 over x to the 4 when you bring it to the right side. Similarly, from positive 4y cubed, it becomes negative here when I brought it to the left side. Look at here to the left side. I have dy over dx common in all the terms. So just take dy over dx common from the left side. Therefore, I will have negative dy over dx into 2 over y cubed plus 1 plus 4y cubed equals to 1 over x to the 4. I took negative common here. By taking out dy over dx from this term, it becomes positive 2 over y cubed because I took negative common. Similarly, by taking dy over dx common from here, I will left with positive 1 here because I took negative 1 common. Same thing happens here. I left with 4y cubed, positive 4y cubed because of this common negative. When you do back the multiplication and open the parentheses, you will get back the same expression on the left side. I need dy over dx. Therefore, I will divide both the sides by negative 2 over y cubed plus 1 plus 4y cubed to get rid of negative 2y cubed plus 1 plus 4y cubed on the left side. Therefore, my dy over dx will be 1 over x to the 4 into 2y cubed plus 1 plus 4y cubed. When you divide both the sides by negative 2 over y cubed plus 1 plus 4y cubed, this is going to be the final answer. It is implicit differentiation by using method 1.